Okay, so there's no quiz today. Because it's a Muslim holiday and, you know, a bunch of people suddenly got religious, converted to Islam. So, I am Muslim for today. Okay, yeah, so no quiz today. We will just be going through lectures. I will take questions on the homework, though. So, no quiz tomorrow either. Next one will be Tuesday. This is, so 5.5.
The last question, number 17.
17.
Yeah, it says the rate of change.
Maybe you should give me the book, because these are word problems. Okay, so the rate of change of atmospheric pressure with respect to altitude h is proportional to p. Right, so basically that first sentence tells you that p prime is equal to rp. So you know it's going to be exponential. Provided the temperature is constant. At 15 degrees Celsius, the pressure is 101 at sea level. And what is the pressure? Where it says at 15 degrees Celsius, the pressure is blah at sea level. And it's blah when you have that. So what do you notice here? Is this an increasing thing or decreasing? It's decreasing, right? Because at sea level, it's 101. And when you go 100 meters up, it drops to 87. So this is a decreasing function. So it's proportional, but it's proportional in the decreasing sense. So we have to think of this as a decay function. So that we know. And it says, what is the pressure at an altitude of 3,000? So how do we get to that? Basically, this means that the equation that governs it looks like this, right? And now we'll just plug in both points. So we know that I think we want h here. Right? We're not measuring things in terms of time anymore. We're measuring in terms of height. So here we know that when height is 0, we have that P is 101.3 kilopascal. I don't care about the units. So this means that 101.3 is equal to P0 e to the 0, which means P0 is this. Right? P naught is that. And we know that when h equals 1,000, our P should be 87.14. So this means 87.14 should be equal to the P naught, which I know is 101.3 e to the minus r times 1,000. So I can use that to solve for r. So r is going to be, well, I'm going to divide by this, so it's going to be 87.14 over 101.3. Then I would log that to get rid of the e. Then I would divide by minus 1,000. So that's my r, and then I can plug it into this function. This means that P is equal to 101.3 e to the minus r, so that's just going to give me ln 87.14 over 101.3 divided by 1,000 times h. So that's going to be the equation that governs this relationship. And so now finally we can answer the question. We had to get to that before we could answer the question. What is the pressure when the altitude is 3,000? So pressure when h equals 3,000 is, just plug in 3,000 here. P of 3,000, 101.3 e to the ln of 87.14 over 101.3 over 1,000 times 3,000. Right, so that just 3 times this and e raised to that times that. You plug that into our calculator, but we don't have calculators, so I will leave it like that. Part B. What pressure is at the top of Mount McKinley? So now you just plug in H equals 6187. So 7.14 divided by 101.3 over 1,000 times 6187. Yeah, that'll be it. So telling us that it was proportional told us that it looks like this equation. So I know it's going to be one of my PERC formulas. I realized that as I increased in altitude, this guy decreased, so I know it's a decreasing function. And then that means I have this equation with a minus r. I'm being governed by h, not t, but the same principles apply. Plug in the 2 coordinates that I was given. I was able to figure out what the equation was, and with that, now I can answer anything, right? So by plugging in, they asked me for the pressure all the time, so I just plug in the given altitude that I needed, and that gave me the answers. Questions?
You just read it as 101.3 times 87.14 over 101.3 to the 0.617 over 1,000 power. You know what I mean? Like without the e.
You can write it without the e. You would have something like 101.3 times 87.14 over 101.3, and you'd raise it to the power 6187 over 1,000, or 6.187. We need the same thing. And of course, this guy you could simplify, but I'm not in the mood to do that now. Without a calculator. So there are a bunch of ways you could write it. I don't particularly care for doing this. That's good enough. The negative is here, but our formula had a negative also. So the negative canceled the negative. Right? And that makes sense because log of 87 over 101 is actually a negative number. So this is already negative implicitly. So I know it's still decreasing. The power is negative. Questions on that? Other questions? Questions on anything else? 15. Start over here. Okay, so it says, when a cold drink is taken from a refrigerator, its temperature is 5 degrees Celsius. After 25 minutes, in a 20 degrees Celsius room, its temperature increased to 10 degrees Celsius. What is the temperature of the drink after 50 minutes? And when will the temperature be 15? So, what's going on here? What kind of equation am I going to use? The Newton's cooling law, right? So I know that the temperature is going to look something like A e to the kT plus the surrounding temperature. So now it's just a matter of figuring out what this constant is, what that constant is, and what this constant is. Well, we know the ambient temperature, that's just the surrounding temperature. It is now in a room where the temperature is 20. So this is 20. As for figuring out this and this, I need more information, which I was given. I know that when time equals 0, when I just took it out the refrigerator, my big T was equal to 5. So that means I have here 5 is equal to a e to the 0, which means my a equals 5. I also know that when time equals, let's see here. So they asked me the rest of the questions in minutes, so I'll leave time in minutes, right? When t equals 25 minutes, big T was equal to 10. This means 10 is equal to a, which I now know is 5, e to the k, wait, I'm missing something. I missed a 20.
Yeah, that should be 15.
There's a plus 20. So a is actually, a is minus 15. So this is minus 1/5 e to the kt. Well, I know t is 25 plus 20. And now I can solve that for k. Once I have that, I'll be able to answer the questions. So I'd move the 20 over, I'd get minus 10 divided by minus 15. So I have 2/3. ln of 2/3 divided by 25 equals k. So this means my temperature is given by minus 15 e to the ln of 2/3 over 25 t plus 20. You can notice here that when t equals 0, my temperature is 5. And of course, if you plug in t equals 25, the temperature will be 10. So that's the equation that governs this situation. Another thing you can notice that is as time increases, this quantity, because it's a negative, will decrease the quantity, which sort of, it makes sense, right? Because you're going from, yeah, makes sense with the situation. Okay, so what did they ask us? 15. What is the temperature after 50 minutes? Just plug in t equals 50. Temp at 50 minutes is t of 50, which is minus 15 e to the ln of 2/3 over 25 times 50 plus 20. Temperature is actually increasing because you're subtracting a smaller number. And again, we don't have calculators, so it's good enough to leave the answer like this. So that was part A. Part B. When will the temperature be 15? So what do I have to do for that?
Temperature and T is 15 equal.
Which T equals 15? The big T, because that's the temperature. So I said 15 is equal to minus 15 e to the ln of 2/3 over 25 t plus 20. And I'm going to solve for little t. So I'm going to subtract 20, I get minus 5. And then divide by 15, I'll get a third. And log both sides to get rid of the e. So this would mean t is equal to ln a third divided by 3 times 25 over ln 2/3. Which makes sense. I'm logging something that's less than 1, so this is negative. I'm also logging something that's less than 1. So this is also negative. Negative divided by negative is a positive, so this is actually a positive number. It makes sense in time. But I don't care what the decimal is because we don't have a calculator. But you should at least be able to look and tell that, oh, the answer sort of makes sense. It's positive what it should be. Other questions? Mm-hmm. Experiments show that the chemical reaction takes place at 45 degrees Celsius. The rate of reaction to blah is blah. Find the expression for the concentration. So that's just a decreasing, exponentially decreasing quantity. So here we have 7. We're basically told that d of this guy, N205 dt, is equal to minus 0.0005 N205. So the thing is, the trick is here, you're just thinking of this guy as the variable, right? It's sort of like dp dt equals a constant times p. It's the same idea. So I know that this guy, which is the concentration of N205, is equal to some initial concentration, or N205 naught. That's perhaps blasphemy, since this is chemistry, the subscripts actually mean something. Maybe just call it N naught of e to the minus RT, so it's minus 0.0005 T. So I know that's the equation for the concentration. What do I find an expression for the concentration? If the initial concentration is C, so they actually told us what they want us to call this. So that's the expression. Right? The basic idea was to just notice that this looks like dp dt equals minus rp. Looks like. And we know that if a differential equation looks like that, the solution would look like p equals p naught e to the rt. So that's our expression. B. How long will the reaction take to reduce the concentration to 0.9% of its original value? What equation do I solve? Right, 0.9 C is equal to CE to the minus 0.0005 T. So, and divide by C on both sides, the C's cancel. So I just have T is equal to ln 0.9 divided by minus 0.0005. Again, ln of 0.9 is a negative number. Divided by a negative number makes this positive, so it actually makes sense. Yeah. So when they say how long, that means they're asking for time, and so time is what I needed to solve for. And I just set what I want to 90% of its original value. So that's how long. We are moving on. Continue reminding ourselves about trig. I believe last time I was writing down the trig ratios, the 6 trig ratios, when we have to end. So we know that sine x and cosine x, those are the main guys. They told us the coordinates on the unit circle. And by definition, right? So it's not really something you figure out. We just call these expressions by these names. We define what we call the tangent function, which is just the ratio of sine x over cosine x. We define the secant function, which is just 1 over cosine. We define the cosecant function, which is 1 over sine. We also define the cotangent function, which is 1 over tangent, or you can think of it as cosine over sine whenever convenient. These are called 6 trig ratios. 1, 2, 3, 4, 5, 6. They're called ratios because everyone's a ratio. Sine, remember, was opposite over hypotenuse. You thought of this as a ratio. This was adjacent over hypotenuse. I did tell you about SOHCAHTOA, right? I did remind you about that. Everyone, I think, remembers that. It's not that hard to prove where that comes from, but I would assume that you guys don't care. It's not even important. Okay. What else do I want to know? I told you about the quadrants. The all students take calculus. I told you about the signs in the different quadrants, how to find multiples of the special angles, divide the trig functions at the special angles. I drew the graphs. Oh, the tangent graph is a pretty important graph to know. The other ones don't show up that often, but tangent shows up often. So the graph of y equals tangent x is something you should remember. Notice that it is sine over cosine, which means whenever cosine is 0, this guy's undefined. Cosine is 0 as every odd multiple of pi over 2. So 1 times pi over 2, 3 times pi over 2, 5 times pi over 2, etc. Right? Also minus pi over 2, minus 3 times pi over 2, minus 5 pi over 2, minus 7 pi over 2, etc. Right? And the graph looks this. It's asymptotic here, passes through the origin, goes like that. And this pattern repeats. That's the graph of tangent. That you should know. You should also remember how to graph them. Graphing with transformations. We're not going to do much of this right now, but we are coming back to something where we're going to use it. We're going to use it in, I think it's chapter 9 where we see it again. We're going to talk about something called polar coordinates, which we're going to graph things called polar curves, where we're going to need to remember how to graph certain trig functions. I'm only going to remind you how to graph different variations of sine and cosine, because those are the ones that are going to show up. We don't really need the other ones right now. So for example, if y is equal to a sine kx minus b plus c, or y equals a cosine k x minus b plus c. A, k, b, and c are just constants, right? Then we can tell a few things about the graph. For example, we can figure out what the amplitude is. Who knows what the amplitude of this graph is? It's the absolute value of a, right? Amplitude is a distance. It's how far you were raised from the baseline. I'll draw a generic example over here while we're talking about it. So the amplitude is a. There's something called the phase shift, which is a fancy name for the horizontal shift. That's B. There's also the vertical shift, which is C. So on your graph, you take an original sine graph, you shift it up or down by C. Let's pretend C is positive for a second. So let's say C is here. That's your new center line. The amplitude is how far you go up and above and below this center line. So we can go up by a distance A, and we would go down by a distance A. So that would be the maximum value, and this would be the minimum value. B talks about where you start horizontally. So let's say B is positive over here. You'll put the number there, and that's where you're going to start drawing your principal period. Speaking of period, that's how long it takes to complete one revolution. The period is equal to what? It's actually 2 pi divided by the absolute value of k. That would be the period. There's something called the, I don't know, I've heard it called many different things. Let's call it the interval for now, which is just the period over 4. Why is the period over 4 important? Turns out that sine and cosine comes in 4 sections. So at any given time, I cut this into 4 equal sections. One, the whole thing is the period. And of course, the length of each one is going to be the period over 4. Right? The length of each of these sections here. Right? So basically, if you want to do something like graph a sine, you have to remember how the sine function behaves, right? So I did tell you about the graph of sine before. It turns out you can think of sine in 4 sections. This is the 0, pi over 2, pi, 3 pi over 2, 2 pi. Sine starts at the middle, then it hits the top, then it hits the middle, then it hits the bottom, then it hits the middle, right? So sine would look like that. If it's negative, it'll go upside down. But you can think of it as 4 sections where it does one thing. So if I know this is a sine and the A is positive, I know the graph will start here, then go here, then go here, then go here, then go here, and I just connect the dots. Right? If I know the graph is a cosine, it also comes in 4 sections and behaves in a particular way as well. The cosine starts at the top, then hits the middle, then hits the bottom, then hits the middle, then hits the top. Right? So you connect the dots there. That's how cosine behaves. Right? So let's do some examples. Did everyone copy this down? Sketch this guy. Y equals minus 2 sine, let's see, x minus pi over 4 plus 1. I don't know how much space this is going to take me, so let's just start there. So you're given this graph, you want to sketch it. Right? So when we hit chapter 9, you're going to have to come back here and remember how to do this. Okay, so what are we going to do? First, we're going to figure out the amplitude A, right, which is, well, amplitude is going to be 2. I know that the phase shift is going to be power of 4. I know that the vertical shift is 1. What about the period of this function? It's just 2 pi, right? Because my k is 1 here, right? So I look at this, I automatically see that a is minus 2, k is 1, b is pi over 4, c is 1, right? And that gives me all this information. So I know that the interval here is just going to be 2 pi over 4, which is pi over 2, which makes sense. That didn't stretch it at all. So now I go over here, and I can actually draw what this picture looks like. So let's say that's the x-axis. Start by doing the c, which is plus 1. So you start here, 1. That's your new center line. It's not a part of your graph, so you draw it very faintly. Amplitude says it's 2. So if I'm at 1, what's my maximum? So it'll go up 2 to a point 3. I'll go down 2 to a point what? Minus 1. Right? Where do I start my graph? At the phase shift, which is at pi over 4. So I'm going to start here at pi over 4. Right? Now my period over 4 is pi over 2. Right? So I know this is going to be in 4 sections. So if this is pi over 4, what's that going to be? Just going to be pi over 4 plus pi over 2, right? Which I can think of as 2 pi over 4, right? So pi over 4 plus 2 pi over 4 means the next part is going to be 3 pi over 4 plus 2 pi over 4. This is going to be 5 pi over 4. Plus 2 pi over 4, this is going to be 7 pi over 4. Plus 2 pi over 4, this is going to be 9 pi over 4. And my graph is a negative sign graph, meaning I start at the middle, then I go to the bottom, right? Into the middle, then to the top, then back to the middle. And so my graph looks like that. So if someone asks you, this continues forever, of course, but I'm just drawing the principle here. So if someone asks you to label these points, for example, sometimes you'll need to know that. You know that this point will just be 7 pi over 4, comma 3. Right? You can label any of these points that you choose because you know all the values for it, and you know what it would look like. You could also, a lot of times when you're sketching things, the intercepts are going to be important. You're going to see y later, especially in chapter 9. How would I figure out where these points hit across the x-axis? How do I know when I hit the x-axis? Plug in y equals 0. So for x-intercept, as always, you set y equals 0. So you have 0 is equal to minus 2 sine x minus pi over 4 plus 1. How do you solve that? You can take 1 to the other side, you get minus 1 divided by minus 2, so you get a half. And this gives you sine of x minus pi over 4. Where does sine give you a half? Pi over 6. Right? Remember that table, the 1, 2, 3, 3, 2, 1. Half comes at the left end, so that's pi over 6. So this means the angle is pi over 6. So x minus pi over 4 is actually equal to pi over 6, plus of course 2k pi And so x would be pi over 4 plus pi over 6 plus 2k pi. And so I can actually simplify that, right? This is 5 pi over 12. Right? So the first one will actually be 5 pi over 12. And for the second one, it will be 5 pi over 12 plus 2 pi, which is 24, so this will be 29 pi over 12. Is that okay? Bring the minus 1. Divide by 2. I know that sine of this equal to a half, so sine is either this or that's not this one. That one will hit. The next one for this guy will hit 2 pi away from that. This one is for the other quadrant, right? So this means is if I'm in Q1, right? Where else is sine equal positive a half? In quadrant 2, right? All students. So in quadrant 2, what would be the principal angle here?
Sine pi over 4 to pi over 6.
What is this?
5 pi over 6.
5 pi over 6. Why is that 5 pi over 6? Remember that thing I was telling you about? How to cut up your circle? You have 0, you have pi. You divide this into 6 pieces. You divide that into 6 pieces. The first one is pi over 6. The second one in the second quadrant will be 1, 2, 3, 4, 5 pi over 6. Right? So this is one of your answers. This is the other one of your answers. They both have sine equals positive a half. So in the first quadrant, I'm going to hit at 5 pi over 12. In the second quadrant, I will hit at pi over 4 plus 5 pi over 6. Plus 2k pi. So this would be 26 pi over 24. So 2 into that goes 13 pi over 12. So that's kind of annoying. Usually when we get to chapter 1, we're not going to have phase shifts, even though you could. But they're going to make it easy on you. They won't give you a lot of phase shifts. The numbers will work out a lot easier. But this is how you could do it if you had to. Besides, finding intercepts are going to be important. And when we get to chapter 9, you'll realize how important. Is there anything I should tell you about? Oh, something else you need to know about sine and cosine. Do you remember things called odd and even functions? I think I erased the wrong side of the board now. Okay. Odd and even functions. How do you know a function is even?
F is equal F negative X. Function of negative X equals
If f of minus x equals f of x, the original, right? So for example, y equals x squared is an even function, right? We put f of x equals x squared. Since f of minus x would be equal to minus x squared, which is the original x squared, right? Which is the original f of x, right? It turns out that cosine is also an even function. F of x equals cosine is also even, right? So this means cosine of minus x is just equal to cosine of x. Right? So if you have a cosine of and there's a negative in the angle, you can essentially ignore it and it wouldn't really make a difference. Right? And how do we know? Describe graphically what it means to be even.
Symmetrical.
Even means we are symmetric about what? About the y-axis. Now if you look at the graph of cosine, it looks like this. It goes on forever. And on this side it would look like this. And you'll notice that about the y-axis you have the mirror image. Right? So if I pick a random x value here, it gives me this y value. If I pick its negative, it'll actually give me the same y value. Right? So because I know that cosine has that property, I know it's even. It doesn't matter if I take the positive angle or the negative angle. It's a mirror image. It's going to give me the same y values in either case. So even means you're symmetric about the y-axis. Cosine has this property. So technically this is sort of calculus. This means if f is even, so a little bit of calc 1 here, not too much, then if I take the integral from minus a to a of f of x, what is that?
0. No. If it's even, it's the same number.
You can rewrite this as 2 times 0 to a of f of x, right? You can only worry about half of it and just double the answer, because it's even, okay? So that's just something that will make our integration easier for us if we know ahead of time that our function is even, which it's easy to check. Right? There are going to be a lot of trick questions that depend on these two things. Let's talk about odd functions. You're odd if f of x is odd if f of minus x equals the negative of the original function. Right? So example, f of x equals x cubed is odd. Right? Since if I take f of minus x, I would get minus x cubed, which is actually just minus x cubed, which is the negative of the original f of x. Right? So that's an odd function. Also, as it turns out, f of x equals sine x is an odd function. So this means that sine of minus x is the negative of sine x. So notice in general, you can't factor things out of the angle. But when the angle is actually multiplied by -1, you can apparently factor out the -1. It's not because you can factor outside of angles, you can't. But because it's an odd function, you can have that. So odd means we're symmetric about what? Symmetric about the origin. And sine has this property. Sine looks like this. Continues, goes back like that. Symmetric about the origin means you can rotate it like that, 180, and you get the same thing. Or you can think of it as two motions. Flip it in the y, and then flip the result in the x. Right? So if I take the right side, flip it in the y, and then flip it upside down, I get the left side. Right? That's symmetric about the origin. You'll also notice if I pick a random x value here, I get a certain y value. If I pick its negative, I will get the negative of the original y value. So sine has this property of being symmetric about the origin, and it also says when I take the sine of the negative of the angle, I get the negative of the sine of the original angle. So sine is odd. As far as calculus is concerned, if f is odd, then this is 0, right? Because one side will be the negative of the other side. So if I integrate from 0 to a, I get some number. If I integrate from minus a to 0, I get the negative of that number. And so when I add them together, I get 0. And so at some point, you're going to see something like minus a to a of some crazy function. Going to be like a monstrous function. You're like, oh my god, I can't integrate that, right? And the trick is going to be, it's odd, right? If it turns out, if this crazy function is odd, then you don't have to do anything. It's 0, right? I'm warning you right now. You're going to see, oh my god, how does Jhevon expect me to do that in an hour and 15 minutes? Well, it's because it's a trick question. So yeah, if I do something like minus 1 to 1, that's a nice odd function. xe to the x to the 4th dx. We're going to learn to integrate things similar to this, but this actually does have an antiderivative. Or let's do something like this. Right? So that's an odd function, right? Which, by the way, does not have, if we didn't have limits on here, we'd be screwed, because you can't actually integrate that. But knowing that this is odd, because when I plug in a negative x here, it makes no difference. When I plug in a negative x here, I get to factor out a negative, so I know it's an odd function. That's 0. Right? What this is, no clue, doesn't exist, can't do it. But putting on limits here, realizing it's odd, means the answer is 0. I don't need to actually know what it is. Okay. So yeah, so review trig, finding angles, SOHCAHTOA graphs, odd and even, the calculus. Is there anything else we need from trig? I don't think so. I think I told you enough to figure everything out. Except now we're going to look at inverse trig functions. So now we're going to actually do the inverse, but we're going to do it in the calculus 2 context. We're going to figure out how to do calculus with inverse trig functions. Go. So now no one has any excuse with trig. I did trig in high school. I told you everything you need to know from trig. Except the inverse trig functions, which I'm going to go over now. So now you're going to know everything you need to know about trig. So this is officially the start of 5.6, the inverse trig functions. So, trig functions, remember, we spoke about this slightly before, for a short period before. They're not one-to-one, so their inverses require a restricted domain. Right? So we looked at sine, for example. We looked at y equals sine x. Realized that this guy looked like that, went on forever. Right? It failed the horizontal line test, meaning it was not one-to-one. So what we did was we cut off a piece of it. Right? We cut off the part from minus pi over 2 to pi over 2, and we ignored the rest. So the restricted sine inverse function is going to use this fact. What we do now is reflected in the line y equals x. This gave us the sine inverse function. People often mistake this for the reciprocal. It's not the reciprocal, so they have alternate notation for it. It's called the arc sine function, because it doesn't mean 1 over. 1 over sine, remember, is cosecant, which is a completely different function from this one. This function looks like, of course, I flip this in y equals x, so it's going to look like this. The x and y values get switched. So now I have pi over 2 is here, minus pi over 2 is here, 1 is here, minus 1 is here. Right? So I know for the sine function, the sine inverse function, its domain is between minus 1 and 1, and its output has to be between pi over 2 and minus pi over 2. Right? Similarly, and I'll summarize all this information soon. Similarly, we look at the cosine function, y equals cosine x. Cosine looks like this. And what we did in that case is we cut it from 0 to pi. We looked at that region and ignored everything else. Okay. And then we flipped that guy in the line, y equals x. So this means that y equals cosine inverse, which is the arc cosine. Looks like this guy. So it goes from 0 to pi. And then it goes from, I didn't put that correctly. The arc cosine graph would look like, this would flip over there, so it looks like that. This is pi, that's 0, this is 1, this is minus 1. This is the arc cosine graph. It's rare when we're going to need to know what these graphs look like, but it's helpful sometimes. The one you need to know what it looks like is the tangent inverse graph, which I'm going to also do. So notice that this one works between 0 and pi. Right? So what we have is the following. Also, if you look at y equals tangent, let's do that one. That one we restricted from pi over 2 to minus pi over 2, not including these, and so we flip this guy or the arc tangent. And this guy actually has an infinite domain because his range is infinity, right? It goes right up to positive infinity, down to negative infinity. So here the domains will go from negative to positive infinity. But they will not pass a height of pi over 2 or go below a height of minus pi over 2. So this guy looks like an S. This graph you should know. Right, you'll be required to know what that graph looks like. It shows up pretty often. Everyone okay so far? Hopefully I'm not introducing any unfamiliar ideas. We haven't gotten to the new stuff yet. This is still sort of a review. Let's see, what else do I want to tell you? I want to tell you all that stuff. I'm debating. It's like running on 6 lines. In summary, it's just not real easy. Okay, so y equals sine x is 1-to-1 for x between pi over 2 and minus pi over 2 inclusive. Y equals cosine x is 1-to-1 for x between 0 and pi inclusive. Y equals tangent is 1-to-1 for minus pi over 2 to pi over 2 non-inclusive. Y equals, this next one let's edit secant, which is 1 over cosine, so it's going to be similar to cosine. Again, it's 0 to pi. However, we cannot be pi over 2. X is not equal to pi over 2 because cosine is 0 there. Y equals cosecant is 1-to-1, where sine is 1-to-1, so it's minus pi over 2 inclusive to pi over 2. Of course, here x cannot be 0. Y equals cotangent is 1-to-1 for 0 less than or equal to pi less than or equal to this. So that's some properties of the original trig functions. This gives us the properties of some of the inverse trig functions. So y equals arcsine for so what I'm telling you here is the range, which is often the more important of the two things to learn or to know for the inverse trig functions. So arc cosine, this works when y is that. So I'm pretty much, all the domains over here are going to switch to the ranges over here. Y equals arctangent for y is between pi over 2 and minus pi over 2. Arcsecant or and of course y naught. Y naught equals pi over 2. Y equals arc cosecant for so secant is 0 to pi, yes. Cosecant is minus pi over 2 to pi over 2. Y not equal to 0. And y equals arc cotangent for in particular from these sine inverse of sine x equals x if x is in this range. So one of the reasons why you need to know this is that it doesn't always work that the inverse function gives you x for these trig functions. That's why you need to know where this actually works. However, sine of sine inverse of x is just x for all x between 1 and negative 1. Cosine inverse of cosine x equals x if x x is between 0 and pi, and cosine inverse of x equals x if x is between minus 1 and 1. Let's look at some examples where this is important. So you know I'm not just writing this down because I like writing stuff down. And again, just to emphasize, these guys are the important ones. You'll see these all the time. You'll hardly ever see like these guys where you need to know all this information. So basically focus on these, know the ranges and the domains for the sine, the cosine, and the tangent. Make sure you know what the graph of tangent inverse looks like. The other two you should be able to figure out what they look like, but they don't show up that often. Not in Calc 2 here anyway. So for example, what if I asked you to find sine inverse of a half? Yeah. Right, so we know that since sine of pi over 6 equals a half, we know that sine inverse of a half gives us pi over 6. But what's sine of 5 pi over 6? It's also a half. Why is the answer not 5 pi over 6? Because the domain, right? 5 pi over 6 is not in the range of minus pi over 2 to pi over 2, right? So when you're looking at the sine function, if you want to get your answers, they will come from here, the right side, right? Your angles can take on any value between minus pi over 2 all the way up to pi over 2. 5 pi over 6 is over here. So it's never an answer considered when you're looking at the inverse function. So that's something you need to know. The trig functions, they repeat their values. So the inverse functions, though, they restrict them. Your sine inverse is restricted to the right side of your graph. So you can never pick angles over here as the answer to any problem. Because technically they don't exist over there. Okay, let's look at another one. Find sine inverse of, what did I have here? Minus radical 3 over 2. What's the answer? Huh?
Negative pi over 3.
It can be pi over 3.
Negative pi over 3.
Right, so I know, so basically what I'm saying is if sine of x is equal to minus radical 3 over 2, what is x? That's basically what I'm asking. Right? So basically you look at the 3 pi over 2, we know what sine of what gives you 3 pi over 2, right? Pi over 3, right? So pi over 3 would give you 3 pi over 2. The other guy over here would be 2 pi over 3, right? The guy over here would be 4 pi over 3. The guy over here,
6 pi over 3.
this would be 5 pi over 3, right? Now we know that all students take calculus, right? So if you're looking at, for the negative values, where would we look? You'd be looking down here. Now, is the answer going to be 4 pi over 3 or 5 pi over 3? Neither. Why? 5 pi over 3 is not between minus pi over 2 and pi over 2. Which means you have to think of this angle in a different way, right? Instead of going this way, go clockwise to that angle. You'd actually move an angle of pi over 3 But when you go clockwise, what happens? You take its negative pi over 3. Right? So this tells you that sine inverse of minus radical 3 over 2, you'd actually take that as negative pi over 3. So don't be fooled. There are a lot of values, but you have to pick the right one. It would seem that one of these could work, but it only works on the right side, so these guys are automatically disqualified. So you're like, to be negative, I have to be in the fourth quadrant. So is it 5 pi over 3? The answer is no, because your answer has to be in this range. So you have to think of your angle in a different way. Go clockwise instead of counterclockwise. Right? So that's going to be your answer. Find cosine inverse of minus radical 3 over 2.
Negative pi over 6.
5 pi over 6.
So I'm saying if cosine of x is equal to minus 3 over 2, what is x? That's what I'm asking, right? You're going back to the original angle. Is it negative pi over 6?
5 pi over 6.
What's cosine of negative pi over 6? It's this, exactly, cosine is even. This is exactly the same as positive pi over 6, which is positive radical 3 over 2. So that's not right. It cannot be negative pi over 6.
5 pi over 6.
So you know, to hit something like radical 3 over 2, pi over 6 is going to be your reference, right? That means you take pi, you divide into 6 pieces. The first guy is pi over 6, but cosine is positive in this quadrant. You move to the other quadrant. That's 5 pi over 6. Cosine is negative in this quadrant. Do I take that as the answer? Yes, because this is between 0 and pi. So cosine inverse of minus radical 3 over 2 is 5 pi over 6. Hmm?
7 pi over 6 will be positive, so you don't do it.
No, 7 pi over 6 is bigger than pi, right? So your answer has to live in between 0 and pi. 7 pi over 6 is bigger than pi, so 7 pi over 6. So technically what you are thinking of is 11 pi over 6. Wait, all students take calculus. Yeah, 7 pi over 6 is here, where your cosine is negative, but it's not taken because we're passing a range, right? You have to think of how fast you can stretch this function. Because remember, we cut off a lot of the function to make this work. So you have to be careful of what values you're taking. That's the whole point.
How does the cot inverse graph look like? Cosine change inverse graph look like?
I don't know.
Thank you.
I could figure it out, but I'm not really in the mood. It's not something that I have memorized because it never shows up. You know what I mean? I don't have a very good memory, believe it or not, so I only memorize what I have to memorize. I memorize a few things and then and know how to get from one thing to the next in case I need to derive anything. I'm very minimalistic when it comes to math. So, cotangent inverse, I have no idea. I could figure it out, but I don't know it off the top of my head. Now let's talk about calculus, differentiating inverse functions. A couple ways we can do this. We can use that formula for the derivative of the inverse, which we've used before. there are other ways to look at it though, so I can say if y equals sine x, this means sine inverse of y equals x, right? So what I can do is say something like, take the derivative of this. If I take the derivative of this, what notation do I want to use? D dx of sine inverse y. Take the derivative of both sides, d dx of x. Basically, this gives us sine inverse of y prime times the derivative of the inside by the chain rule. This side gives us 1, which means that y prime is 1 over the derivative of sine inverse of y. Right? So I'm just using the same formula again. And we actually figured this out last time. This was just 1 over cosine y, which ended up being, when you drew the triangle, 1 minus 1 over x squared. I derived this a slightly different way last time, but it doesn't matter. Okay, so I know that the derivative of sine inverse is 1 over the radical of 1 minus x squared. This means, by the chain rule, if I have derivative of sine inverse of u, that is just u prime divided by the radical of 1 minus u squared. So that's our formula. The others are derived similarly. They are, so I did this in far more detail in a previous class, so you can look back in your notes if you want to see the detailed derivation. So there are a bunch of rules that we need to know. So we know that the derivative of sine inverse of u is u prime over the radical of 1 minus u squared. The derivative of cosine inverse of u, turns out it's not that different from sine inverse, it's just actually the negative. So sort of weird, but that's how it worked out. The derivative of the tangent inverse of u is just u prime over 1 plus u squared. That guy's important. We'll talk about that a lot coming soon. The derivative of cosecant inverse of u is minus u prime over the absolute value of u times the radical of u squared minus 1. The derivative of secant inverse of u equals the positive version of that, so u radical of u squared minus 1. And the derivative of cotangent inverse of u is minus u prime over 1 plus u squared. Those are the rules you need to know. And again, these ones are the super important ones. I mean, you'll see some of these pop up in your homework because this is Calc 2 and they want to emphasize the rules, but beyond Calc 2, you're not going to see these guys very often. You can essentially forget them after the test. But these guys, you need to know these. They come up show up all the time. And they're also going to help us out with a lot of integrals when we get to them. We're going to know how to solve many integrals by reversing those rules. So let's do some examples. Find the derivative. Y equals cosine inverse of 5x. And y equals sine inverse of 1 minus x squared. C. Y equals 4 arctangent x fourth d equals x squared plus 1 sine inverse for x. You have these, right?
Nope.
I have one more example, but we'll wait. Okay, what's y prime? Negative 5 over radical 1 minus this squared. So it's 25x squared. That's it. Y prime here.
Negative 2x.
Minus 2x. The derivative of this guy divided by
Square root 1 over x.
1 minus 1 minus x squared squared. Right? Which you can expand that if you'd like, but I'd like to not. Y prime here.
Something. So 12x cubed over 1 plus
48x cubed.
This is 12x cubed, but remember there's a 4 here.
Yeah, 4 multiplied, 48.
So it's 48x cubed divided by
1 plus
1
9x8.
9x16.
which means at some point I
8.
8
Right, 8.
which means technically at some point I could ask you what's the antiderivative of this, and you should be able to tell me that. More on that later. Y prime
2x arc sine 4x plus 4 over 1 minus 16x squared.
2x arc sine of 4x plus
4 over the square root. Wait,
4 over the square root
1 minus 16x.
1 minus 60 squared. Right? Just do the product rule. Differentiate this, leave that alone. Then you differentiate this, leave that alone. Plus y equals x squared. How do you find y prime? You can't solve for y, so what do? Implicit differentiation. So you differentiate this, which is going to be what?
X plus 1.
The derivative of the inside, derivative of x is 1, derivative of this, y prime divided by the radical 1 minus x plus y squared plus y prime equals 2x. And now you just solve for y prime. So this would mean your y prime, I could factor this out of 1 over the radical of 1 minus x plus y squared plus 1. On this side I'll have 2x minus that.
How did you factor out y prime from the first one?
Yeah,
How did
shouldn't there be one plus?
No.
How did you factor out
Yeah,
y
you
prime from the
can't.
first one?
Addition. Oh, right. No.
It's addition. I split this fraction into two pieces, into this and that.
Oh.
Right? The 1 over blah, I moved over there.
Oh,
And then this y prime is a common factor. I can factor it out. There's 1 left over here, and there's 1 over blah left over here. So then I have y prime would be 2x minus x plus y squared all over 1 plus which can be simplified, but I don't care to at the moment. Right? You could just simplify this by multiplying by this over itself. Right? Complex fraction, multiply by the LCD. Just a couple more examples and we're out of here. Well, do I want to do some important limits? Like I said, the arctan function is going to be very important. Remember what y equals arctan looks like? Arctangent x. Maximum is pi over 2. Minimum is minus pi over 2. Looks like an S. It's asymptotic, always approaching this but never touching it. So this means, of course, what if I say the limit as x approaches infinity of arctangent? I would get pi over 2. Or the limit as x approaches minus infinity of arctangent. It's minus pi over 2. What about the limit as x approaches 0 of arctangent? 0. These are the important ones, not really. So for example, what if I did the limit as x approaches 3 from the left side of tan inverse of x minus 3. Now as x is approaching 3 from the left, what happens to the inside function here? The top will approach 3, the bottom would approach 0, but from what direction? 3 from the left side, which means you're like 2.99999, right? So 2.99999 minus 3, you get a slightly negative number, right? So it's 0, but it's negative-ish, which means the inside will approach negative infinity, right? So I see tan inverse, and I'm taking a limit. Obviously something fishy is going on. I'm going to look what the inside is. If the inside goes to infinity, it doesn't matter, because I know this. So this is minus pi over 2. Things like that show up all the time. They like using arctangent. Now, I showed you guys how to do this before, so I don't know if I want to go through them again. Simplifications. Things like simplify cosine of sine inverse, or tangent of cosine inverse. With this we can end. This is the end of the chapter. But does anyone remember how we did this?
No, we can use u, right? 1 over square root u that. No?
It's not a derivative. I never said differentiate. I said simplify.
You do that both.
Remember we said theta equal to sine inverse of x, right? Which means sine theta is equal to x, which means we could have gotten a triangle where this would be x, that would be 1, because this is x over 1, opposite over hypotenuse. This guy would be the radical of 1 minus x squared, so that cosine of sine inverse equals cosine of theta, which is just 1 minus x squared. So cosine of sine inverse is the radical of 1 minus x squared. What about tangent of cosine inverse? Same idea, right? So you let theta equals the cosine inverse of x, which means cosine of theta equals x, which means I can set up this triangle where my x is the adjacent side. That's the hypotenuse side, which means that this side is, again, 1 minus x squared. And so now, if I say the tangent of cosine inverse of x is just the tangent of theta, because my theta is cosine inverse, but tangent of theta is what? Opposite over adjacent. So this expression actually simplifies to that. Again, that's going to be important when we are doing integrals as well. We're going to get to something called trig substitution, which is crazy and annoying, and you're going to need to know how to do things like that. That ends that chapter. So homework for that due tomorrow.
No.
We have class tomorrow. Tomorrow's a Tuesday schedule, don't forget. Pass up the homework to the front and get out of here.